So I also saw in your research you do blue mining. Could you explain what this is? Just simply mining in the ocean, correct? Or you research it?
This is quite a controversial topic. We work purely the science side of it. So currently there is not really any kind of legal mining in the ocean. Primarily, that's at least not in the international oceans. People can kind of do what they want within their own areas of research. On my side, we provide a lot of information about how mining might impact the seafloor and how mineralization is distributed. So we're not involved at all in any kind of active mining. We don't do any mining research. We don't do resource estimates. We don't do any of the that side of it. But what we do try and do is provide information on how and where we think impacts might be, what we think systems might look like at depth, and how and where we think mineralization occurs. So it's difficult to describe the diversity of things that we do. But for example, we did like a project where we were looking at mine plume dispersal. So one of the primary things that people are worried about with seafloor mining is that the sediment plume that will be produced, it will be damaging because you can, if you have things that can't move away, you can bury them under sediment. So one of the experiments that we did on Tropic was to look at, we produced a fake plume and then we measured using an autonomous vehicle where it was going and how it was dispersing and what was falling out where and what the density of sediment was and where that was happening and how that was controlled by ocean currents and that kind of thing. So those are the kind of bits of information that we provide. But really, we don't do mining, we do science.
Well, I figured you didn't do the mining part. I figured you were evaluating what was there and how it would affect things. So that makes perfect sense. So what did your sediment study uncover or cover?
Well, so our sediment study suggested we needed another sediment study. What we found actually was that for this experiment that we didn't get fallout over a particularly wide distance. So most of the material fell out of the water column very close to where the plume was being generated. And we didn't see a huge amount of evidence for it further away. But it was very much like a sort of trial study. Actually, just at the moment, we're proposing to do a much bigger study that would do a much better job of it. So producing a more realistic plume with the right chemistry, the right grain sizes, that kind of thing. And then surveying it in multiple different ways to see how and where we'd expect to see fallout. We'll see if that gets funded. But there's a lot of interest in protecting the environment around seafloor mining. And I think that it's, as I said, it's a controversial topic and it's difficult to talk about because people feel very emotively about it one way or the other. As a scientist, I try not to have an opinion, I suppose, but I think that what it is an opportunity to do is to provide the information that we can about the environment, about the impacts, about the ecosystems before any activity starts, which isn't something that we've been able to do on land. I don't know whether or not that will happen. I don't know how seafloor mining will progress in the future. And I don't know what decisions will be taken by policymakers. But my hope is that we are able to characterize ecosystems and impacts before there's any active mining.
I like that. So I guess we should back up here a minute and explain, why would you even want to mine the ocean floor in the first place?
Yeah, so I mean, there are a number of different reasons that people want to mine the ocean floor. The primary one is that there are a number of different elements that have been defined as critical. So where the future sort of demand is likely to outstrip supply, and where supply can't be met by our current resources or by recycling. Now, these are all predictions. So there is obviously errors on this, and there'll be technological advances. So perhaps what we predict we need now might not be the case in the future. For example, at the moment we think we need maybe a lot of lithium for batteries, but battery technology is advancing all the time. So actually maybe that won't be the case. But there are some metals that look like they are particularly critical and where it's very, very hard to meet them with like our current sort of resources. And some on land mining resources are also not great. They don't have great human rights records. Some of them use child labor. They're not very safe. They're not very environmentally friendly. So mining as a whole topic is really quite complex and probably more than I can cover. And so there is a push to find new resources for these very sort of critical needed elements. And I mean, one of the primary drivers for that is moving towards net zero. So sort of developing greener technologies, green energy production, electric cars, those kind of things. But I don't know if that would be the only driver, because we also put those elements in things like computers and phones and technology that isn't just for net zero. So there's an economic push both from green development, but also from industry, just in general, as there would be for any kind of resource, really. And so in order to meet that demand, one of the options is to look at seafloor resources. And there are some places in the ocean that are particularly enriched in certain elements that are thought to be useful. The big one that people are talking about at the moment is the Clarion-Clipperton Zone. So that's a big area in the Pacific where there are what we call nodules. So ferromanganese nodules, they're usually called because they have iron and manganese in, but they also have a lot of other things in as well that are potentially useful. I mean, in that area, they basically just precipitate out of seawater, but they take a long time to form, and they look like cannonballs. They're like big round black rocks on the seafloor that just precipitate between like the sort of water and the sediment interface. And so because they're loose, they're relatively easy to collect. But there's also an issue with collecting them, because I think I said earlier, but in the sea, when you have a hard substrate, you tend to have an increase in biodiversity. So most of the area around the Clarion-Clipperton Zone is like a sandy, sort of deserty area, and stuff lives in there, but the biodiversity is lower than if you had a hard ground. And when you have nodules, you provide a hard ground, so then they are colonized by certain species that can then produce an environment that is appealing to other organisms. So you get this sort of feedback of increased biodiversity. So there's a lot of work going on now about whether or not you can sort of replace them with other things. So yeah, because they're easy to pick up, however, this is sort of technologically the closest we're coming to major exploitation of the seafloor. Now, if you're a company and you want to do that, there's a lot of different loopholes you have to go through. So there's in international oceans, so in international areas that aren't owned by any country, it's all governed by the International Seabed Authority. And there's lots of information about them online. If people are interested, they could go and have a look. But they go through quite a strict process where you have to apply for areas, you have to meet a lot of different criteria, you have to do certain impact assessments, etc. And then when you submit all of that information, you can get certain licenses. So at the moment, nobody has an exploitation license at all for that area. There are none that have been issued. And that's because at the moment, the regulations for environmental impacts aren't really set. So we don't really know. The ISA haven't yet declared, at least to my knowledge, they haven't currently declared what the regulations are going to be for those areas. So what companies would have to do if they wanted to exploit. So the only licenses that have currently been issued are for exploration. So this is just to look at what's there, to conduct studies of biodiversity, to do some geochemical analyses to see what their potential resource might be. And most of the companies have been pretty tight-lipped about that. So it's hard to know at the moment really what the resource is there and whether or not and how economically viable it would be to exploit, because mining the seafloor is extremely expensive and technologically very difficult. We talked about how difficult it is to do any kind of seafloor exploration. And so if you're running quite complicated equipment in deep water off a vessel, your costs are going to be really, really high. So companies will have to balance costs against whether or not they think that their resource is going to be worth that. And I don't know what the outcomes of those kind of studies are going to be. But yeah, the idea is that you could help to meet a demand that can't otherwise be met. And it's not the only option. I mean, you don't have to mine the seafloor. There are other options for increasing the amount of resources we have. So you could look at mining in regions that previously were inaccessible. So I wouldn't support this, but for example, in the Arctic, where you're getting melting due to climate change, you're opening up pathways, you're reducing permafrost, those kind of things. And all of a sudden, there are areas that previously were inaccessible that now are accessible. So potentially that's a resource. Or you could mine at lower grade, so where you have lower concentrations over much bigger areas in regions that we already have mines, but where currently it's not economically feasible to exploit them. But for that to be the case, metal prices would have to increase. So it's difficult because none of the options are perfect. When we talk about resources, I think it's very easy to be against everything. And I understand why people would feel that way. Like, I personally want to protect the environment and I don't want to see damage to our natural world. This isn't the area I'm really researching in, but it's not something that I'd want to see. But also, we tend to disconnect our own usage of things from where they come from. So when you look around at your house or whatever, if it wasn't grown, it probably came out of a mine. So unless we are also prepared as a society to change the way that we consume metals and the way that we consume technology and the way that we consume everything, really, then there's going to be a demand for it and people are going to continue to make profits off extracting it.